Welcome to Technologyverse.
Hey everyone, and welcome to today's Explainer. Today we are going to completely demystify exactly how cloud storage works. We hear the word cloud constantly, right? But today we're actually going to peel back the curtain to uncover the real principles and models of modern cloud storage management. If you want a direct, no-nonsense look at the architecture that literally powers the modern internet, you are in exactly the right place. Let's get started. So let's dive right in with a super simple question. Where exactly is the cloud? It is incredibly easy to fall into the trap of thinking about it as this weightless, invisible, magical entity just floating around above us. But we really need to burst that bubble immediately. The cloud is deeply grounded in physical reality. We are talking about massive, warehouse-scale data centers just buzzing with electricity and huge cooling fans. We're talking about hundreds of thousands of hard disk drives and solid-state drives sitting in physical metal enclosures, all stitched together by a ridiculously robust global fiber optic network. Basically, the cloud is just someone else's physical computer, but managed at a scale that is almost unimaginably brilliant. Here is our roadmap for today. We're going to cover 1. Inside the physical cloud. 2. Block, file, and object storage. 3. Choosing your cloud model. 4. Data redundancy and availability. 5. Cloud synchronization and access. And finally, 6. Securing the cloud. All right, kicking things off with Section 1, Inside the Physical Cloud. Okay, so the absolute magic trick that makes cloud computing actually work is virtualization. Think about it. If you just had these massive, clunky physical servers, allocating resources to people would be incredibly rigid and super wasteful. Virtualization fixes that. It acts as an abstraction layer. It takes those giant pools of physical processors, memory, and storage, and literally slices them up into flexible, dynamic virtual machines. This means those physical resources can be shared among multiple individual virtual systems completely on demand. It slashes server wastage and allows the cloud to be incredibly elastic. Honestly, without virtualization, the modern cloud just wouldn't exist. So let's look at how a major provider actually handles your data on all that physical hardware. Let's take Google's file system, Colossus, for example. When you upload a file, Google doesn't just, drop it onto one single hard drive. No way. They do this fascinating multi-step dance. First, your file gets broken down into smaller chunks. Second, to lock things down securely, each chunk gets assigned its own unique encryption key. Third, these chunks get distributed across completely different machines using a service called D, which basically manages access to each machine's disk capacity. And finally, they replicate those chunks across different clusters. Why go through all that trouble? Well, at a planetary scale, individual machines and racks are definitely going to fail periodically. By chopping your data up and scattering it, they ensure that even if a machine completely dies, your data is totally durable. Nothing is ever lost. Moving right along to Section 2. Block, file, and object. Now, when we get into the logical layer, the crucial thing to understand is what we call the big 3 storage types. First up is object storage. This stores data in a flat namespace, so absolutely no hierarchy at all. It uses unique identifiers and lets you attach virtually unlimited custom metadata. That makes it incredibly scalable, though, heads up, it can have slightly higher latency. Next is block storage. This takes your data and chops it into equal-sized blocks. It uses very little metadata to keep things extremely efficient, which translates to lightning-fast performance and super low latency. And finally, we have cloud file storage. This is your traditional, comfortable, hierarchical storage, folders inside of folders. It uses standard file-level protocols, making it incredibly intuitive if human beings need to access and share directories. So which one do you actually pick? Let's do a rapid-fire rundown of the perfect use cases. You're going to want object storage for massive amounts of unstructured data. Think millions of images, huge video archives, backups, and modern AI workflows where limitless scale is the whole point. You'll want block storage for applications that demand high-speed, direct access. Stuff like real-time analytics, high-performance computing, relational databases, and running virtual machines. And then you'll want cloud file storage when you've got real people needing concurrent access to a shared system. It's perfect for collaborative work environments and shared team directories. Picking the right storage personality is absolutely vital for your project. All right, Section 3, Choosing your cloud model. Okay, let's talk deployment. Think of the public cloud kind of like renting a super convenient, fully serviced apartment. It's a multi-tenant environment hosted by providers like AWS, Google, or Azure. It's highly elastic, you only pay for what you actually use, and you totally bypass all those huge upfront hardware costs. But you are sharing the building with other tenants. The private cloud, on the flip side, is like building your own ultra-secure fortress. It is a single-tenant environment dedicated solely to your organization. You get ultimate control and security, which is absolutely fantastic for strict compliance, but you are the one bearing the cost of managing the whole thing. Now, in reality, most enterprises today use a hybrid multi-cloud approach. They blend. They get the rapid, on-demand scalability of the public cloud, but they keep their most sensitive workloads locked down safe in the private cloud. And just to really drive home how massive this shift to the cloud has become, take a look at this jaw-dropping stat. According to projections, worldwide end-user spending on public cloud services is expected to exceed a whopping $1 trillion by 2027. $1 trillion. That right there tells us that mastering these cloud storage principles, it isn't just some niche IT skill anymore. It is quite literally the absolute foundation of global business infrastructure. Which brings us to Section 4, Data Redundancy and Availability. Okay, prepare to totally geek out for a second, because this number is just mind-boggling. 99.9999999999999%. Yes, that is 16 nines. That is the actual durability guarantee Microsoft Azure offers for data over a given year if you use their top-tier geo-redundant storage. But wait, how on earth do they manage to guarantee that your data will almost certainly never, ever be lost? They pull it off through brilliantly layered redundancy. Think of it as the old rule of 3 for backups, but engineered at a staggering scale. At the base level, you've got LRS, or local redundant storage. This is where data is replicated multiple times within a single primary data center. A step up from that is ZRS, zone redundant storage, which takes those copies and spreads them across multiple physical zones within a single region. But for those glorious 16 nines, you want GRS, geo-redundant storage. GRS synchronously copies your data locally and then asynchronously shoots a copy over to a secondary region that is literally hundreds of miles away. So even if a widespread natural disaster takes out a whole city's power grid, your data is perfectly safe and sound on the other side of the country. Moving on to Section 5, Cloud Synchronization and Access. Every time you use a virtual disk like Google Drive or Dropbox, there is a hidden busy bee algorithm just constantly running in the background. This sync process is very much a two-way street. First, it checks the local files sitting on your computer, then it checks the files up in the cloud. If you created a brand new document locally, boom, it uploads it. If your coworker added a new file to the cloud side, it downloads it right to your machine. The ultimate goal is to make sure your local folders and cloud folders are perfect identical twins. Now, step 5 is where it gets a bit tricky. If you both happen to edit the exact same file at the exact same time, the algorithm spots a version conflict. When that happens, it usually taps out and requires you to step in and manually pick the correct version. But here's the thing, synchronization isn't just a human user thing. It relies heavily on APIs. APIs, or application programming interfaces, are basically the secret digital handshakes of the cloud. They're the software intermediaries that let totally different systems talk to each other without missing a beat. So when a developer writes a quick script to automatically scale up servers, or when a payment app securely talks to a cloud database, they're using APIs. They strip away the manual effort and let us automate incredibly complex storage tasks entirely on the fly. And finally, we arrive at Section 6, Securing the Cloud. Obviously, the absolute bedrock of cloud security is encryption, taking your data and scrambling it so it's completely unreadable without the right authorization. And we've basically got two main methodologies here. Symmetric encryption is kind of like having one master key that both locks and unlocks the vault. Because it only uses that single key, it is super fast and incredibly efficient if you're processing massive data sets. Asymmetric encryption, on the other hand, is a double key vault. You use a public key to lock the data and a totally separate private key to unlock it. Now, it's definitely computationally heavier, but it provides seriously enhanced security, especially for sensitive stuff traveling over public networks. Both of these methods are absolutely vital for protecting your data, both when it's in transit over the network and when it's just sitting at rest on the storage drives. But actually encrypting the data raises the ultimate trust decision, right? Who actually holds the keys? You essentially have two choices here. With customer-managed keys, or CMK, your own organization generates and controls the master lock. You have total, absolute control. But if you lose that key, your data is gone forever. No do-overs. Alternatively, you can opt for provider-managed keys, where the cloud provider, like AWS or Azure, just handles the hassle of key generation, rotation, and safe storage for you. It is way simpler to manage, for sure, but you are placing a tremendous amount of trust in that provider's internal security infrastructure. And that brings us to a really fascinating final thought for today. The cloud is definitely not static. As AI workloads start demanding massive, low-latency object storage, and as emerging quantum computing threatens to potentially break our traditional encryption models, the landscape is shifting rapidly. So, I want to leave you with this provocative question. Will your current cloud storage and encryption strategy actually survive the next decade of evolution? It is a huge challenge, and one that absolutely requires us to keep learning and adapting. Thank you so much for joining me on this explainer today, and I highly encourage you to keep exploring the amazing mechanics behind the cloud. See you next time.
If you really feel the video is helpful, click like, share, and subscribe button. Thank you for watching.